Hello, everyone. I wish to go over just a couple more examples with a little bit more difficulties on applying fundamental theorem of calculus part 2. And here you probably see that I have this indefinite integral table with us because they are useful in the case of indefinite in the case of definite integral. Take the example of 31, which I imagine there might be some difficulties handling these power rule where there's a fraction as the power, right? So I'm going to start with that one. Integral from 0 to 1. Okay, from 0 to 1. Whoops. 0 to 1, wait. Here, 0 to 1, okay. This font's a little bit too big. Let me make it smaller. There we go. And we have x multiply inside the parentheses of cubic root of x plus fourth root. Okay, fourth root of x dx. Don't forget dx, okay? It's a common mistake, missing dx. All right. We're integrating this function, and we said there's no product rule, quotient rule. So we have to make this, we have to multiply x inside, right? So in that regard, we're going to have to combine, we'll multiply x to the inside, multiply x inside there, right? And then what do we do? Well, this is x raised to the power 1/3, right? So you're going to have to operate it. X raised to the power for 1/3, right? X multiply x raised to the power 1/3. We have the same base, and we add the exponent. So basically, we apply this property, okay? Base to the power of m multiply base to the power of n, and that equals to base raised to the power of m plus n, okay? So here we're gonna get same base, 1 plus 1/3. 1 plus 1/3, we're gonna make it improper fraction, so that's gonna be 4/3. But we're gonna do the same for the other one. So multiply x raised to the power of a quarter. Okay, so 1 plus a quarter, that's going to be x raised to the power 5/4. So now by this time we can apply the power rule for each. But in terms of writing these properly, and which is also this is also the reason why I want to show you how to show work. We have the power rule. So for each piece, you're going to use power rule, but you also have to know this is a definite integral. So when you work with it, you have to write it down properly. So this is a 4 quarters. Okay, so 4/3 plus 1 raised to the power of 4/3 plus 1. Okay, so we're going to come back to calculate that fraction. Plus, okay, the second one, apply power rule. So that's going to be 5/4 plus 1. Okay, so I'm applying the power rule and dropping the constant. Okay, when power is not a -1, and that's our case. So x raised to the power of 5/4 plus 1. And this time you don't add a constant. You don't add a constant because this is a definite integral. So what you can do is that you can put in the bracket and the 1, 0, 1. You can mark it this way. All right. So from this step to the next step, you need to be very careful to write it properly. Okay, because there are multiple things to take care of. You need to do the antiderivative. At the same time, you have to attach to apply the a fundamental theorem of calculus part 2. Okay, so that's what you have to be aware of. Okay, we're applying fundamental theorem of calculus part 2. So this is how we write it. And next, we will work in the bracket and simplify it. So this is arithmetic. 1/4/3 plus 1. So that's going to be 1 is going to be 3/3. So that's going to be 7/3 under 1. Right? 7/3 under 1. And that's going to be 3/7. Multiply x, right? X to the power of 7/3. Really, we just have to be very patient. When we work with this kind of question. And the 5/4 plus 1 is 4/4. So it's going to be 9/4 in the denominator, right? So flip over, we have 9 under 4. So now x raised to the power of 9/4. It's really a fraction. It's really about a fraction, right? So we're going to attach these over here, right? And the next, we're going to apply fundamental theorem of calculus part 2, which you're going to take the bracket, right? Take the bracket, and for subtracting the bracket one more time, okay? But substitute x by 1, which you're doing capital F of B, okay? Substitute x by 1. And over here, you substitute x by 0, okay? And of course, in this case, the latter bracket is 0. And you could actually skip this step, but I'm just showing you as a procedure that you are doing that. So in the end, this piece is 0, and that the former piece is 3/7 plus 4/9. To make it perfect, you probably have to find common denominator. The common denominator is 63, right? To get 63, we do 7 times 9, that's 27, plus 4 times 7, that's 28. So that's plus 28 over 63 equals to 63 under 55. Done. Okay, so that's 31. 33, let's do 33 because it has something to do with the logarithm. Okay, but this question itself is not that difficult. So we got 33, the lower limit is 1, the upper limit is 2, and we're integrating x over 2, subtracting 2 over x dx. Okay, don't forget to attach the dx, okay? And what do we get here? Well, we can actually use the antiderivative, right? X over 2. The antiderivative for x over 2 is 1 over, oh, we can put divided by 2 as 1/2 and put it on the side. And then work on the antiderivative for x, which is x squared over 2, right? Subtracting the antiderivative of 2 over x, you can put the 2 outside, and the antiderivative of 1 over x is going to be ln absolute value of x. Do we add a constant? No, we don't. We don't add a constant, right? Because it's a definite integral. So once again, you can use this notation, and the lower limit is 2, the upper limit is, lower limit is 1, upper limit is 2. And then you organize your term a little bit. So that's going to be 4 under x squared 2 times ln x. So by this time, you can apply the product, the fundamental theorem of calculus part 2. So basically, you have 2 brackets. One bracket subtracting another bracket, and by x, the number 2 is going to, which is, this is the b, and that's the 1. Oops, 1. Oops, 1. Okay, and simplify. What do we get? Okay, so make sure you write it properly. And this is a 4. 4 over 4, that's 1. So that part equals to 1 minus 2 times ln 2, subtracting, this is 1/4, right? 1 squared over 4 is 1/4. Subtracting, ln 1 is 0. So near the end, we have 1 minus 2 times ln 2, subtracting 1/4. So in the end, 1 minus 1/4 is 3/4, subtracting 2 times ln 2. That will be the answer. You're done. Okay. There are a couple of, trick questions. They're not super hard, but I'm going to show you how to, I'm going to leave 37 for you, okay? And you can see technically, you know how to do it by when I do 38. On 38, right, we have integration, and this is, of course, is a definite integral. The lower limit is 0, the upper limit is pi over 3. There. Okay, and then we got sine theta tangent square theta divided by secant square theta. Secant square theta. Whoops. Secant square theta. D theta. Okay, and make sure I copy the question correctly. All right. Okay. So now let's see what we get. Equal, no product rule, no quotient rule. We can't apply those, okay? Don't invent them. So what we can do is that we're going to take the denominator, divide into the numerator, each at a time, one at a time. Okay, so I'm going to put a bracket for clarity. So sine theta divided by secant square theta plus, okay, sine theta multiply tangent theta. You know what? You guess what? I think I see something else. Okay, let's do this. We're going to factor it out. We're going to factor out the sine theta on the top because of sine theta plus sine theta times tangent theta. So we're going to factor it out tangent theta. And so the top becomes 1 plus tangent square theta d theta. Okay. And then what? 1 plus tangent square theta. This is a secant theta. This is secant square theta. So here we go. We can reduce the secant square theta, right? So we will only be left with the sine theta, right? Because we simplified. So you can see it needs some, and then we're almost done. We're almost done. What's the antiderivative of sine theta? Is negative cosine theta. Right? But don't forget it's definite integral, right? The antiderivative of sine, because you can see the table is pretty handy. But we also have to make sure we have the limit marked from 0 to pi over 3. Don't forget these. Okay. Last, almost the last. Okay. When we're applying the property of the applying the theorem of fundamental theorem of calculus part 2, you may want to leave the negative sign outside. Okay, so we just have a cosine theta, which is going to replace by pi over 3 first, subtracting cosine 0. This, for me, it's to avoid mistakes. Okay. Of course, you don't have to do it this way. Okay, but I usually do it this way to avoid, messed up with signs. Cosine pi over 3 is 1/2. Okay, subtracting cosine 0 is 1. So inside the parentheses is a negative half. So there's a negative sign outside. So the final answer is 1 over 2. So that way you would know how to do 38. Then you would know how to do 37. Okay, 39, similar to something before. 43, hint. Okay, 43 is a hint. I'm going to give you the hint. It's a factor, the denominator. It's t to the power 4 minus 1. So 43, I'm not going to do it for you. T to the power 4 minus 1 can be factored into t squared minus 1 multiply t squared plus 1. Then you will know what to do after, okay? So last but not least, I'm going to do 45 for you because this one involves absolute value, okay? So we have definite integral from -1 all the way to +2. And the function has a absolute value. What are we going to do about it? Right? Absolute value function is a continuous function. Continuous function has antiderivative. So there's no doubt we do have solutions. Okay. It's just how we're going to handle it. And the interval is from -1 to +2. So one thing you can do here to make it simple is that this integration, you separate it on x dx, subtracting 2 times integration and just absolute value of x dx. Just keep it simple. So this part can be done easily. But on the second part, because the interval is between -1 to 2, right? So I'm going to draw a little number line here. Number line, right? So it's from -1 to +2, right? And there's a 0 there. And the absolute value of x, right? The absolute value of x on the interval between -1 to 0, we're taking absolute value of x, right? So I'm going to mark it this way. The absolute value of x on this interval, it is equals to -x. Okay, so make the interval just a bit longer. On this other interval, right? X on this other interval, the absolute value of x is the same as x. The absolute value of a negative number is opposite the absolute value of a positive number, or 0 is the same. So we apply that property. So for the latter, okay, on the first one, it's pretty straightforward, right? The antiderivative for x is x squared over 2, right? And the antiderivative, I'm sorry, and the limit you just plug in, okay? There's a -1 and there's a 2. We're gonna follow the fundamental theorem of calculus part 2. -2 on this part, I'm gonna separate the interval, okay? And here it is the rule, right there. Oops. Right here, you see this property. We're applying this property, okay? Because the rule changes, we have different rules, right? We have different rules. So knowing that, we're going to have the interval, the integration changed from, and we're going to add this other one. One is from -1 to 0, and the other one is from 0 to 2. And on this, from -1 to 0, the function is -x dx. On the other one is x dx. See, the interval is split, okay, according to the root change. According to the root change. Then we just finish. Okay, then we're on this part, we're gonna carefully do this. Okay, 1/2, right? X squared, so 2 squared, subtracting -1 squared. Okay, maybe I should use bracket here. Okay, use bracket. Okay, so this part is complete. This part turn into capital F of B subtracting capital F of A. Okay, we're applying fundamental theorem of calculus part 2. Subtracting, okay, inside this interval, inside this, inside this bracket. If you want to keep it simple, I would like to keep it simple. There's a negative sign here, so you can put the negative sign outside. The antiderivative of x is going to be x squared over 2. Don't forget the negative sign in front of it. Okay, and then the limit is going to be from -1 to 0. Okay, so that's the definite integral on this part. Okay, the next part is going to be still the antiderivative of x is x squared over 2, but this limit is 0 to 2. Okay, so we want to make sure it's clearly written down correctly. Inside this bracket is 4 minus 1, so it's 3, so 3/2. So this part is done. Subtracting 2, And the second bracket, right? We have this negative sign here. We'll just leave it out, okay? So, and there's a half, right? There's a half. There's a half. There's a half there. You know what you can do? The other thing you can do is that you can take this 2 and multiply inside. Okay, and this 2 and this 2 will reduce, and that 2 and that 2 will reduce. So you will end up with something like the following. You no longer have this 2, just x squared. And you no longer have this 2, it's just x squared. So that seemed to be a little bit easier, isn't it? If you want to apply, I'll just leave it like that, okay? So next, we're just going to be carefully taking care of this situation, okay? The first part, I'm going to keep it, so I'm going to substitute by 0, right? So it's going to be 0 squared minus -1 squared. So that part is done, right? So this piece turn into this piece, okay? This piece, okay? X squared. So 0, the upper limit, -1 is the lower limit. So right there. The second part, right? This piece is going to turn into 2 squared minus 0 squared. So we apply fundamental theorem of calculus part 2 one more time. Ooh, finally, we are almost there. 0, so this is a negative, this is a 1, -1, another negative, so this is going to be +1. That's 0, and that's 5, right? Simplify, okay? So 3/2 minus 10 over 2. That equals to -7 over 2. Okay, I think that's right. If there's any problems, let me know. But the main thing for this last example is the handling of sign change in the case of absolute value. All right. So if you want to try other examples such as 44, 46, go for it. They are pretty similar situation, except they're a little bit harder. They're a little bit harder. Okay. You know, I'm going to do 46 for you. Okay, 46 for you. 46 is integration from 0 to 3 pi over 2. 3 pi over 2. And the function is absolute value of x. Yes. Knowing sine function is, you know, the sine curve, right? You know the sine curve from 0 to pi is above x-axis, right? Sine curve. All right. Well, let me show you the sine curve, which everybody knows. Everybody knows the sine curve. I'm going to make some adjustments so it's only relevant, right? So from 0, 3 pi over 2, 3 pi over 2, say 6. Okay. So if you look at these points, right? If you look at these points, so this whole interval 0 to pi is covered, right? So there's a 0 to pi, that's 0 pi. That interval is above x-axis, right? So we're gonna have to split in this interval. And the next one, all right, from 3 pi over 2, where is the point of 3 pi over 2? Sine 3 pi over 2 is -1, so let's look at that interval. So that's gonna be 3 pi over 2, 3 pi over 2, oops, not 3, comma, -1, that's the point on the curve. Okay, I think I should have shown the other point. Okay, why it didn't show? Oh, never mind, my fault. It's pi comma 0, not pi comma 0, my bad, sorry. Okay, so the area of our interest, okay, so this represents, of course, absolute value, right? Absolute value of sine at this piece, you know, sine function in this piece, this is in the negative, so it's going to be flipping up. So I'm going to show you the curve, right? The absolute value of sine of x. Wait. Sine of x. Okay, I think the symbol has to be entered this way. Change the color. There we go. So we really are trying to find the area. Okay. Let me enter another point. Whoops. Delete. So this point, you can see the flipping over, right? You can see the flipping over right there. So the area that we are looking for, okay, the area we are looking for is, of course, all of these, okay? This area underneath the curve. And this piece, right? This piece, 3 pi over 2, and so that area is added. So this area, okay, this area. So that's the area we're adding up for this integration, okay? But the sine curve changes sign. I mean, the sine curve between pi to 3 pi over 2 is negative. How do we deal with this? Right? So this is how we're going to deal with. We're going to apply the properties of absolute value. Okay, wait. Clear. Okay, so we're going to apply the properties of absolute value. So once again, I'm going to use number line to illustrate with the help of this curve, right? So here's the 0, right? And here's the pi. And here is 3 pi over 2. Three pi over 2. Okay, 3 pi over 2. You can see in this interval, right, sine, we're going to split the interval. We're going to split the interval. The interval will be split into 2 pieces. Okay, one is from 0 to pi, and the other one is from pi to 3 pi over 2. And in this interval, the absolute value of sine, or sine is positive in this interval, so that's going to be the sine x. No change. No change. Okay. To drop the absolute value, okay, on the second interval, on this interval, the absolute value of sine, so in this interval, sine x, absolute value of sine x is the same as sine x. In the next interval, okay, the absolute value of sine x is negative sine x. Okay, so let me make this just a little bit larger so it covers. All right, so that's a splitting of the interval. So in the second part, it's just going to be negative sine x dx. Okay, and we were applying this property number 4. That's it. Finish. Let's finish this question, right? The antiderivative of sine is negative cosine. And this is going to be processed on the interval between 0 to pi. Okay, plus here I'm going to bring this negative sign outside. So this is just going to be minus. Okay, so this negative sign just moved outside. And what do we get here? Right, so here's a minus. The antiderivative of sine is negative cosine. So we have a negative cosine. Well, negative makes positive, if you wish, right? And the interval now, this interval is different. Okay, it's pi, and the upper limit is 3 pi over 2. All right, okay. You can, of course, here you can actually use unit circle to determine the sign as well. Okay, but anyway, so now let's do minus. So we're going to put in a bracket. So I have a cosine pi minus cosine 0. Oops. Cosine 0, subtracting. But here we're going to do negative, that makes positive, right? Plus cosine. So this time is going to be cosine 3 pi over 2 subtracting cosine pi. Boom. All right, equals to, we're going to wrap this up. Negative, right? Inside the bracket, cosine pi is negative 1. Cosine 0 is 1. Plus this piece, right? What do we have? Cosine 3 pi over 2 is a 0 minus cosine pi is negative 1, so it's negative 1. We need to be careful, okay? Too many negative signs. Let's see what we get here. Negative 2, there's another negative sign, positive 2. Plus 0 minus negative 1, that's plus 1. So in the end, we have 3 as our answer. So the total area that we have shaded, okay, this piece and half of that piece, that's going to be 3. Okay, so that's the application of absolute value function in definite integral. Okay, so that's all the work. Let's see. I think it's time to close. Thank you for watching.